Hello, my name is Liz, and I am presenting on a browser-based 3D modeling software called Tinkercad. I selected Tinkercad because it's very versatile. It can be used in a host of classes depending on how involved in STEM you want your class to be. It can be used in everything from social studies and geography to use it to create maps, to English to build uh, settings for a novel, to science. I'm going to show you how to build a 3D molecule. To math, you can use this for a very easily. You could use this for geography or geometry. I'm sorry. My objectives and goals for this lesson is to teach you how to build a very simple 3D molecule that you can then turn around and 3D print for very quick and very easy. My intended audience for this video would be for a student to experience what it's like to 3D model a molecule. A lot of times schools can't afford to buy an entire model kit, but using this, they can do it on their own and manipulate those pieces just as if they had it in their actual hands. The two ISTE standards we are going to address today are first, 5B, which is to design authentic learning activities that align with content area standards and use digital tools and resources to maximize active deep learning. So in this situation, we're going to use Tinkercad to model molecules. This is something that is obviously an authentic learning activity. They're going to be able to get hands-on and embrace this without a whole lot of cost involved, which is really beneficial for schools. And then the other one we're going to look at is 6C, which is to create learning opportunities that challenge students to develop a process, to use a design process and computational thinking to innovate and solve problems. So this is model making. Model making uses that design process and computational thinking, and we're going to solve problems. We're gonna make some molecules here today. All right, so here's the finished product that we're going to try to make. It is a water molecule. So the first thing we're going to do, you're going to log in to tinkercad.com. You're going to hit join now and enter your class code. I'm going to come back up here and I'm going to make a new design. All right, so here is my work plane. Now my work plane is bigger than my 3D printer, so I'm going to change our settings here so that I can potentially print this. If you live in Johnson County, the Johnson County Library will 3D print for you for free if you don't have a 3D printer that you can utilize. We happen to have one in my classroom. All right, so here's my print plane, or my work plane. It's the exact size and shape of my 3D printer will allow. So as long as I'm building in this workspace, I should be pretty good. All right, so we tend to conceptualize molecules as being a perfect sphere. We know that they probably aren't in real life, but for the purpose of this, we're going to think of them as being a perfect sphere. So we're going to build a water molecule to start off with today. You can build whatever molecule you want in your own free time, but today we're going to start out with a water molecule. We know that they're super important for biology, so let's start there. So we're going to pull in 1, 2, 3 molecules, 3 spheres to represent molecules. So each of these is a molecule. So we have an oxygen. Let's change its color. Let's do red for oxygen, and we'll keep the hydrogens blue. So H2, so we've got 2 H's, 2 hydrogens, and 1 oxygen. Beautiful. All right, so we know that our hydrogens each have 1 proton, and our oxygen has 7 protons and 7 neutrons. So our oxygen is going to be considerably bigger than our hydrogen. So let's make it 3 times bigger. So we're going to do 3 in each of these dimensions. There we go. So make sure every dimension, you make it 3 times bigger. There we go. He's pretty big. Perfect. And I'm going to change my view here so I can see the side. We actually want this to be much like it is in real life. So I'm going to move my work plane down here. There we go. And I'm going to bring these hydrogens up. So they're roughly in the middle of my, I'm sorry, my screen's being a little funny. There we go. I'm bringing them up so that they're roughly in the middle of my oxygen. There we go. There we go. So it's up 3/4 of an inch there. Let's see here. How far up are you? We want you up 3/4 of an inch as well. There we go. Perfect. So they're even now. All right. Let's look back down from the top. They're a little close. I'm going to move them out. There we go. Because we want to see how exactly they are bonded to this oxygen. Which brings me to the next point. We need some bonds here. So we're going to use this cylinder to represent our hydrogen bonds. We know that in actuality, our bonds are made by the electrons between the valence shells of each of these atoms. But in this situation, we're going to go ahead and represent that with this cylinder. So this cylinder is going to represent our valence electrons. All right. So I've made it nice and tall and skinny. I'm going to lay it down on its side. I'm going to bring it up to, it ran away from us. There we go. I'm going to bring it up to right in between these hydrogen molecules. There we go. And now I'm going to change my view to the top so I can put him connecting our hydrogen to our oxygen. So I'm going to grab this curly arrow and I'm going to spin it around. There we go. All right, 1 hydrogen connected. Now we have a hydroxide ion. It's negatively charged. It would be a base. All right, and now we have a water molecule. There we go. That's it. That's all we have to do, and we have a water molecule. We have 2 hydrogens, 1 oxygen, connected by 2 bonds, 1 bond each. And remember, those are covalent bonds. They would each be sharing their electrons. All right, guys, have a great afternoon.